This video is an algorithm to determine the number of factors, to find the number of factors any given number has. It's a pretty straightforward algorithm. I was only able to come up with one optimization, but it's a pretty good one. Um, so let's get started. This is the equation, the factors equation. You give it any number, and it'll return an array with the number of factors in it. The only optimizations I could come up with is the fact that if I want to find out how many factors, let's say the number 100 has, I don't have to check every value from 1 to 100. All I have to do is check the square root of 100 or 10. So to find out how many factors 100 has, all I have to check is the first 10 values, which is, I think, a pretty good optimization. So what I do actually is I start off by setting my array to 0, to an empty array. I check the first square root of n numbers from 1 to square root of n. So let's take 100 for example. I start with 1 and I say 100 mod 1 has a remainder of 0, so 1 is a factor of 100. But because I'm only checking for the first 10 numbers, I get two factors right away. I get 1 mod 100 mod 1, so I get 1 as a factor, which I add to my list of factors. But by dividing 100 by 1, I also get 100, which is the other factor. So I get two factors from one check. So looking at the next number, which is 2, 100 mod 2 has a remainder of 0, so 2 is divisible by 100. It is a factor, so I add 2 as a factor. I also get the other factor by saying 100 divided by 2 is 50, so the other factor is 50. So I add 50 to my list of factors. So from one check, I get two factors. All I have to do is in this line, make sure that I'm not adding the same value twice. For example, 4 is divisible by 2, right? But so I add 2 to my list of numbers when my n is 4. But 4 divided by 2 is 2 itself, so I don't want to add 2 again since I already added 2. So I just make sure that when I divide the number, whatever number it is, by my number that I'm checking, that I'm not going to get the same number that I'm checking back, because I don't want to add it twice in the list. So that's pretty much it. So the only optimization I came up with in this algorithm is the square root of n. So if I want to check how many factors 100 has, I only have to check the first 10 value. If I want to check how many factors 1000 has, I only have to check the first 100 values. So it is a pretty good reduction right there, pretty good optimization. And like I said, with one check, I get two factors, just making sure that the numbers are not repeated. In the case of 4, 2 times 2 gives you 4, and I don't want to add 2 twice, I only want to add it twice. In the case of 9, 3 times 3 gives you 9, so I only want to add 3 once, I don't want to add it twice. So pretty much what I'm doing is when I find a number which is divisible, I make sure that when I divide it, I don't get that number back. If I get it back, I only add it once, I don't add it twice. So that's it. This is a pretty straightforward, very simple algorithm to find the number of factors. Let's run it and let's see what it says, okay? Okay, so here it is. So I ran it for the first 299 numbers. So it says 1 has one factor, which is 1. 2 has two factors, which is 1 and 3. 3 has two factors, which is 1 and 3. 4 has three factors, which is 1, 2, and 4. If you notice, by definition, a prime number is a number that is divisible by 1 and itself only. So all the numbers that say that it has two factors are prime numbers. So 2 has 2 factors of prime number 3, has 2 factors of prime number 5, has 2 factors is a prime number 7, has 2 factors, again a prime number. The next one, 11, which has 2 factors, again is a prime number. So this algorithm not only tells you how many factors any given number has, but by checking that it has 2 factors, you could determine which numbers are primes. I believe, let's go down, that the biggest number of factors found is 20 in the range from 1 to 299. 240 has 20 factors, which makes it the highly composite number in this range. So that's it. That's the algorithm. Pretty simple, pretty straightforward. The only optimization is that instead of checking, if I say I want to find out how many factors 100 has, instead of checking from 1 to 100, all I have to do is check from 1 to 10. So the square root of n is the optimization here. And from one check, I get 2 factors. Thank you, and I'll see you in the next video.